This video is about vertical shifting of the tan graph. We see again the graph of tan drawn in green here, the original, or what I like to call the mother graph. And on this same set of axes, I want to draw tan theta minus 1. So we notice that the tan theta is a y value. So in this case, we will just subtract 1 from each and every y value of this function. So let us start at, for instance, in the center here around the origin, and if you look at the point E there, if I subtract 0 from 0, 1, then I get minus 1, so the point E now becomes a point Q. If I take the point F, which was 1, and I subtract 1, I get the point R, and so from D subtracted 1, I get the point P. So in this case, I have now 3 points on this new graph, and all I need to do is draw or join these 3 points in a similar way as the green graph is done. So when I do that, I will get this blue graph here. So let us just go through R. Okay, the root will be at Q, so we will have concave up for that part, and we will have concave down for this part here. So we can do for the other 3 that's shown here, the other 3, so I can join this, and that should be concave up, and this is concave down, and concave down, concave up. So these are now the new shifted graph. So if we measure it at any point, even there where it seems that the 2 functions are touching, we will find that there's a distance of 1 in between the 2 graphs. We also look at a period here, and we see the shifting, the vertical shifting did not change the period at all. What happened is the graph, the new graph, is just below the other graph, and here locally we can see a lot of change, because here is what the interesting parts that happening, but up there it just becomes infinity, and down here it becomes negative infinity. On this page I've joined the points electronically, and you can see the blue graph there, which represents the graph of G. So if we fill in again all the necessary details, we see the period is still 180 degrees. As before, we do not have any amplitude because we do not have any extremes, no minimums or maximums. If we look now at the roots, we see that the roots are now at O, R, U, and Z, because this is where this graph intercepts the horizontal axis. And we notice that in this case it happened at minus 135 degrees, at 45 degrees, at 225 degrees, and at 405 degrees, etc., because there are more of them. In general, we can write down the roots by again taking a starting point like 45, so we can say theta is equal to 45, plus the period, which is 180 degrees, which is an element of Z. And we can write it as another formula, but in this case we can just keep it like that. So these are all the roots. And you must always check your answer by substituting values for k, like 0, 1 and minus 1. It's sufficient to take 3 in a row to make sure that that formula holds. In general, we see the vertical asymptotes are still at the same places. They are at theta equal to negative 90 degrees, plus 90 degrees, and theta equal to 270 degrees, etc. So the vertical asymptotes, the general formula for that is theta equal to, again, if we take a number like 90 degrees and we just add a multiple times the period, 180 degrees, where k is an element of z, then I can again write it as 2k plus 1 times 90 degrees, where k is an element of z. The concavity changes now at the points N, Q, T, and W. And now we are wondering whether these two graphs, it looks on this page as if they will intercept each other, and we want to check that. So I see there's a typing error there at the bottom. It should be where it intercepts with tan theta. We're not now interested in the other solution. We want to see whether these two graphs will intercept each other. On this page you will find a summary again of what we've discussed on the previous page, and I see you can read through all of this, check whether all the formulas hold, and then here where I've said what the vertical asymptotes in general is, I made a typo there. This should be 180 divided by 2. So you can now go to the next exercise. To complete your vertical shifting knowledge, I want you to do one on your own, tan theta plus 1, and I've included the graph here with a grid. You can draw it here by first make dots at the specific places where this new graph will go through, and then write down all the relevant detail here. And then you can also see whether these two graphs, tan theta plus 1 and tan theta, where they will cross, if so.